Hello, everyone. Welcome to the episode 6 of the PKI Solutions webinar series. I'm Mark Cooper, president and founder, and I will be your co-host today. We are going to be talking about validating SSL certificates the easy way. And we're going to talk about some of the common problems that we see with SSL TLS authentication and talk about some of the troubleshooting and tools that are available to identify these. My co-presenter today is Vadams, and we're going to go through and introduce ourselves. For those of you that don't know me, I'm the president and founder of PKI Solutions, and I started PKI Solutions about 6 years ago, and we focus just on PKI. We work with both consulting services, support services, and training solutions. And today, my co-presenter is Vadams. Vadams, go ahead and introduce yourself.
Hello, everyone. My name is Vadams Podens. I'm from East Europe, Latvia. I'm working on PKI for quite a long time, maybe about 10 years or so. And I'm focusing on development stuff like programming API and writing integration tools with user interface and console automation like PowerShell.
Excellent. And Vadams is our recently promoted senior PKI developer and is responsible for our new online PKI assessment tool, along with many contributions he's made in the PKI space with the ASN1 editor and so forth. So let's go over what we're going to talk about today. We're going to go through and talk a little bit about the common use case scenarios around SSL TLS authentication. And frankly, if you haven't already heard this, sometimes we'll go back and forth between SSL, TLS. That the primary authentication and mechanism we're really looking at in modern day is TLS. But admittedly, they are used interchangeably, but the primary protocol is TLS. So we're going to talk about some of the common places that you see this. And we're also going to talk about some of the common problems, as well as some of the recent issues that we've had from the browser side of things. And an important thing to note is that TLS is not just a web PKI issue. This isn't something that is only brought about from servers and browsers. It's used in many different places. So some of the things that we're going to go through are really driven by those different use case scenarios. We're also going to talk about some of the troubleshooting things you can do, and we're going to take a look at the SSL Verifier. So this is a tool that Vadams has created, and it's part of our free open source tool program. And we're going to go through how that tool can be used to validate and troubleshoot some of the different scenarios we're going to be talking about today. And Vadams is also going to go into talking about automating the SSL Verifier and some of the interesting things you can do there. So let's get started, and we're going to talk about some of the use cases. When we talk about authentication and web PKI in many different places, SSL TLS is the standard protocol that is typically used for these. And there's many elements that go into this concept of SSL and TLS. Whether it's the certificate component that goes into identifying which host you're talking to, as well as ensuring the information that is exchanged is encrypted and protected. The TLS protocol has many different elements that are involved there. When we talk about TLS, we're typically talking about all of those components, whether it's identifying the host, encrypting information, or any of the underlying components. Now, being PKI focused, we're not necessarily going to go into all of the session level encryption and protocol sides. We're really going to be talking a lot about the identity and the certificate use, because that's frankly where a lot of the problems come from. Now, it's not to say that there aren't issues with negotiating a cipher suite between a browser and a host. Those are certainly problems that are there. But we're really going to be primarily focused at that certificate level. Now, one of the primary things that we're talking about when we're using certificates and we're talking about the web PKI, for instance, is we're trying to validate the host. And we have this implicit trust, and it kind of goes back to the foundation of PKI. If we trust the certificate authority, if we trust the PKI where a certificate comes from, then we entrust the host itself. So in the case of a browser going to a website, the way that we really know that we're at the destination website that we intended is the fact that it can prove that it is that destination with a certificate from a trusted PKI. Now, we probably and most likely do not have that website certificate explicitly trusted sitting inside of a trusted store or specifically programmed into a browser. We're doing this through a implicit trust, meaning we trust the CA where it came from. The same thing happens in other cases when we look at things like Wi-Fi authentication and we're dealing with a Radius server. It too has a server authentication certificate doing a process very similar to TLS that we want to make sure that we're talking to a trusted Radius server. The other thing that TLS and certificates provide is a starting point for session level encryption. If we think about the fundamental problem is a certificate has a single key pair that goes along with it. Inside of the web server certificate, for instance, we've got the public key that goes along with it. And when we want to encrypt information, we can encrypt it with that public key so that the server can read it. Well, that doesn't necessarily provide any type of unique ephemeral encryption between user A and user B. They would both be using the same key. The server would see that, which means anyone that had that server's private key could decrypt that information. What TLS often does is after it validates the server and we're certain we know who we're talking to, it moves to a session level encryption for a couple of reasons. One is it provides that ephemeral set of keys where user A's traffic cannot be decrypted with user B and vice versa. The other thing is it's generally much more efficient. When we're dealing with certificates, we're generally dealing with RSA or asymmetric key pairs. These are very inefficient when it comes to encrypting at scale and in high performance environments. So we need some type of symmetric encryption to move into that is much faster. And that's that session level encryption. Well, in order to generate that session level key, it does use the public key of the server itself to negotiate what it is that symmetric key going to be. And then it stops using that asymmetric encryption and moves to a session level encryption. So it really is kind of that starting point, which means if for some reason we can't adequately use the public and private key of the web server certificate or the Radius server, for instance, we can't move to the session level encryption and actually do some actual traffic. As I've mentioned, Web PKI, it's not the only use of SSL TLS. Web PKI is probably the one that we're most familiar with, but there are many different places where we find SSL and TLS implementations that are done. The other thing that we find is that in the Web PKI space, browsers, operating systems, hosts, they are all following and implementing their own sets of rules. And while there are RFCs around certificates and SSL, TLS, and cipher modes and block ciphers and so forth, they all have their own processes that each manufacturer is building in. So part of the complication to this whole process is, well, what is the browser doing? What is the OS doing? What is the web server doing? What are they enforcing? What aren't they enforcing? And those are some of the things we're talking about today as well. You could have something that is designed and deployed specifically to the RFCs, but have a browser that is doing something distinctly different. And we see this a lot around certificate validation and revocation, and specifically in that many browsers don't necessarily use CRLs or OCSP. Many of them have just stopped doing that altogether. The other thing that we see is the CA browser forum drastically impacts what happens in the Web PKI space. So the CA browser forum, the consortium of manufacturers of both the certificate authorities and the operators of those, as well as the browser, often have new and ongoing changes and regulations and ballot measures that impact how the community will be using certificates as a whole. This doesn't necessarily affect other types of implementations, but one of the things is it causes an impact. If we're used to seeing one particular behavior on a Wi-Fi radius server and our browsers and web hosts are doing something different, it does cause a confusion. There is impact because it just gets people thinking about things differently. So what are the most common SSL TLS use cases that we see out there? Obviously, there's the web PKI, historically SSL. Almost everything's moved to TLS, whether that's 1.1, 1.2. TLS is kind of ever evolving. It is the definitive standard on the web PKI side. We also have use cases with TLS inspection appliances, whether these are Palo Alto or Blue Coat or other types of devices. A lot of organizations that we work with are deploying these devices to be able to inspect outbound TLS traffic from their organization. And this actually affects us quite a bit on the PKI side, because these appliances are frankly acting as middlemen within an environment. It's essentially a sanctioned man-in-the-middle attack, where these appliances are spoofing websites and producing TLS certificates on the fly so they can decrypt and inspect traffic that's exfiltrating a network. They are essentially doing TLS. So this is an interesting scenario where you could have a public website that is following all the proper standards, a browser inside, and in the middle you could have one of these TLS inspection appliances that's not quite doing TLS the right way, or causes a behavior difference when you have one host that's going through it and another that's not. So it's no longer just a two-party TLS. It really is kind of a three-way of our browser, our TLS appliance, and the host, and trying to track down where these problems are coming from. We also have obviously things like LDAP over SSL. So Active Directory has a feature that you can enable where third-party systems can access Active Directory over SSL TLS connections. Mutual authentication scenarios where both the server and the client can authenticate. We see it a lot with things like Wi-Fi, where a client that's getting onto an EAP TLS connection, the client is going to provide a certificate to identify themselves onto the network. Their radius server would have a certificate as well. So we can see this kind of TLS traffic and authentication in both places. So certainly web PKI is not the only place where this tends to happen. So let's talk about some of the common problems, and this really kind of builds up to our opportunity for Vadams to show us the verifier. But some of the common problems that we tend to see, whether it's web PKI or these other use case scenarios, are things like obviously expiring certificates. Almost every organization struggles with certificates that expire for a website or in the chain. It frankly not often that we see things like a root CA expire. They do happen, it's just less frequently, but more often than not, something with the end entity expires. If we're doing mutual authentication, it could be the client certificate that expires, but more often than not, when we see a basic TLS problem, it's usually an expired certificate. We also see issues with certificate chain, where either the entire chain isn't properly trusted, it's not properly transmitted, or maybe we're even chaining and validating through a cross-sign CA, and we're having issues around there. So the ability to actually see what type of chaining and validation is going on is very important. We run into problems with weak TLS versions, where you could potentially be accessing a site that's not using the latest versions of TLS, or maybe it's only SSL enabled. If it's an appliance with a management interface, perhaps it may only have SSL 3.0 interfaces, and if your browser is no longer configured to support SSL and requires, say, TLS 1.1, the certificates may be fine, they may not be expired, but it may not actually be able to negotiate through the proper versions of SSL and TLS to set up a connection. We see problems around redirects and embedded content. So whether it's a website that's redirecting to another site where you may necessarily go out and take a look at the certificate that you're intending to validate, only to find out that that website is redirecting you to another location or through a web host or maybe a content delivery network, and it's a whole other set of certificates. Or sometimes we even see things that it's embedded content. And this isn't necessarily a certificate issue, but if I've got a web page that's HTTPS protected, my browser may actually complain about the site being untrusted simply because it is including content that is being delivered either through another site or is being delivered via HTTP. So in this case, it could be really confusing because your browser may come up and say the site is unprotected. We assume that there must be a certificate issue because it's always the certificate's fault. Not really, but that's kind of where people tend to go. So the embedded content can definitely be an issue. We have issues around certificate validation and the transparency. So certificate transparency of figuring out what certificates have been validly issued and are they in the certificate transparency list and so forth. And obviously, newer requirements with like SANs. This one still pops up a lot. Most of the browsers now are enforcing a requirement that subject names be in the SAN rather than the subject name itself. The last problem I wanted to go through, we recently blogged about this one, is intended to be affecting public CAs, but there's a few scenarios that could come up. And this is the browser change where starting September 1st, all TLS certificates that are issued will only be valid for a maximum of 398 days. So let's just call that a 1 year plus a fudge factor. Where we have concern and why we're communicating this out for enterprises is some enterprises actually get their certificates from public CAs. Some of them are actually subordinated or managed by some of these providers. And we've also seen in the past, some of the past things like SHA-1 to SHA-2, as well as the SAN enforcement, where internal PKIs have been inadvertently caught up in what was supposed to be a public chaining certificate only impact. So this is going to be a change for organizations that may have certificates that are issued after September 1st that have a TLS purpose, server authentication, if you will, and are valid for more than a year. Well, this is going to be a change. Troubleshooting why this is going on. If you're not aware that the browsers are doing something a little different, it's going to be much more difficult to track this down. So I'm going to end by just touching on a couple troubleshooting, and then I'm going to turn it over to Adams, which I know is who everyone's here to hear from anyway. So from a troubleshooting perspective, the most common things that we want to do is go through the chaining. We want to take a look at if there's any type of certificate issue. We want to make sure it's coming from a trusted source. We tend to see this for places for newly deployed PKIs where a server's been set up, but not all the clients are trusting it. Or where someone's inadvertently taken an internal certificate and placed it externally. From the end entity properties, here we're typically looking to see, does the host really have the private key? And it actually happens more often than you think, where somebody has set up a server host and forgotten to give it its private key, or it was exported and imported on another system and the key just didn't come along. So we need to make sure that things like the private key are accessible, but also obviously things like subject alternative names, 1 year validity, and so forth. We also want to go through and think about some of the amended rules that the browsers are doing. And these are the really difficult things to catch. Most of the tools that you're going to find, and even admittedly, our SSL Verifier is really looking at certificates and functionality that's there. The browser change, for instance, with the September 1 year enforcement, there's technically nothing wrong with the certificate or the chain or the validation or certificate transparency if it's valid for 2 years. It's simply the browser itself is going to be throwing an error if it sees that condition. So these amended rules, it's often difficult to check out and validate what's causing an issue, especially when it's just something that's sitting inside of a browser. And then obviously we have those unrelated issues, the mixed content, the redirects. These are the things that sometimes either are pretty quick to find, or sometimes they just take longer. I know I recently had a call with a customer and we were talking about their PKI, and they mentioned they were having a problem with their web server certificate, and they assumed that it was a certificate issue. I went on the site, and using the Chrome debug mode, you can quickly see it was just mixed content. So sometimes these things are a little quicker to find, but if we're kind of heading down the road of assuming that it's a certificate issue, the mixed content may be one of the last things that we look at. So with that, I'm going to turn it over to our co-host Vadams, and Vadams, you're going to do some demos of the SSL Verifier and a couple of scenarios that you thought people would be interested in. So take it away.
Okay, I will try to share my screen. Okay, select this window. Okay, let me know if you can see my screen.
All right, it's loading now, Vadams.
Okay.
There you go. And your screen is shared.
Okay. Okay, so here is a tool I wrote several years ago, maybe for different purposes, but recently I've adapted it to modern scenarios, practices, and rules. So it's in mostly a single window UI. WPF application where you can add host names to a process list and let me add some solutions.com. Okay, we can add okay, and maybe this one SSL.com. So we can process endpoints in a bulk up to 5 entries at once. And we have added a list of servers. So we want to check their ports. Optionally, if it is a requirement, you can specify a proxy server address and credentials for it, but it's not required for us at this point. And we have several configuration options for the tool. So I'm opening settings window, and we have several settings. First one is a search transparency log, which checks public logs for TLS certificate. If it is checked, the TLS certificate must be published in public CT log. If it is not published there, then application will arise error. A strict EQ validation is a check for server authentication for entire chain. Browsers often check for server authentication EQ only in a LEF TLS certificate, while this key usage may not be valid for entire chain. This happens when intermediate CA certificate specifies a custom list of key usages which doesn't include server authentication. Allow user trust is Windows specific setting which determines whether a user store is allowed to get trusted root CAs. By default, only root certificates that are installed in machine store are trusted. If we want to allow trusted root certificates to be trusted from user store, we have to enable this checkbox. Require minimum RSA public key length is quite obvious. It checks for RSA key length in all certificates in chain, not only in leaf certificate, but in intermediate and root CA as well. We can specify which TLS protocols we allow a client to connect to a server. By default, we are using either TLS 1.2 or 1.1. And a list of weak signature algorithms, which is configurable. You can add your own signature algorithms, which aren't considered as strong. So let's fire it with some default settings. Okay, and fire all entries. For every entry, we have a detailed dump log with certificate contents. For every certificate, what extensions, DNS names in subject, alternative names extension. So it's working. Okay, we have ended our scanning. First, we see that first two entries succeeded with a green icon, and the last one ended up with a red icon. First, check certificates section where we see certificate chain for specified TLS endpoint. We can navigate every certificate, view it, and show check for errors. Since first two entries ended without errors, so no error is shown. And it is one case what I have added to the tool is redirect TLS checking. There are cases when you connect to a named endpoint and it redirects you several times until you reach a final endpoint. And with a browser, it is hard to debug this because browser won't show you at which point in redirect invalid certificate appeared. So in this case, we show certificate chains for every redirected URL. So first is google.lv, and it redirected us to www.google.lv. Okay, in a given case, we've got same certificate, but it's not a requirement. You can get different certificates on each redirect. Okay, let me show. Okay. So, and let's explore runhost bad SSL.com endpoint. As we see that leaf certificate is marked with red icon. If we press on it, we see that we see two errors. One is name mismatch and not in transparency log. So this certificate So is issued by DigiCert, but it is issued to wildcard second level subdomain *bedssl.com, and same name is here in subject alternative names extension. But we have connected to a third level subdomain rank.host.bedssl.com, which is invalid name for this wildcard name. This we fire a name mismatch flag. And as I said, we have checked to check certificate in CT log, and it is not logged there. And we can check CA certificates, but they are pretty valid. We can check a few more endpoints, fire them. Okay, untrusted root. As it is, this certificate is issued by CA. We do not trust. We were unable to check for certificate revocation, possibly because CRLs and OCSP aren't available to me. And this CA certificate is not trusted by a system. Another feature we have, it is a report export into HTML report, so you can save it to a file, send via email, print if you wish. It is done simply by clicking this save HTML report icon. It prompts you to save where to save a file. Okay, let's do it. Okay, and open HTML report. This report shows at the top SSL Verifier configuration. So when report was executed, configuration settings, and report summary reflects main grid in the app with general details, and for every entry we have a certificate details node. We can expand it, and we will have a separate entry for each redirected URL like here. First is for google.lv, and the second one for 3w google.lv. We can expand it and get common certificate details like subject, alternative names, serial numbers, public key, and so on, and errors. So no errors, it is in green, and full certificate dump in base 64. You can copy paste this text and save as a certificate file. So for Google, everything looks okay, and we can check what is what happens with wrong certificates. Okay. Yes, and we see same information, certificate details, and explained errors. So name mismatch that and the explanation the certificate is presented. For different website and not in transparency log that certificate isn't published there. So that's all about our HTML report. I would like to add one point about what actually we check. We have about 30 plus certificate and chain validation rules. So here it is. So here is a list of common or not a very common certificate and chain issues. So this one, too long validity, is added for upcoming Apple and Google policy, which stays in effect on September 1st. And some errors are inferred from a built-in Windows certificate chaining engine, like invalid extensions, constraints. They aren't very common, but still happens.
Great. And you know, Adams, one of the things I was going to add in is that this tool is really helpful for, obviously validating a particular website or a chaining engine. And the one bit of advice I would pass along is to make sure that they're using this in a place that is representative of where the problem is occurring. So if there is a particular host or browser or server, for instance, that's experiencing a problem, running the verifier on that same system is potentially important in that it may have a different route. It may be going through a particular firewall or inspection appliance. If you install this on another machine or your host, you may see it very differently. So, you could certainly run it where you desire, but it is often with PKI all about perception and where you are seeing a particular site, and the TLS inspection appliances could really provide very different looking results when you're running this test. Now, Adams, I know you were also going to do a demo of some of the automation you could do with the SSL Verifier, right?
Yes, of course, but one thing is left, that there is a tiny column called days left, which shows how many days left for a certificate before it comes to expiration. And so nearest expiration is 61 day. We can modify threshold to 65. Yes, and rescan this entry, and we will get yellow warning, yellow icon. Okay, yes, it will already see a certificate icon with a yellow triangle. Yes, and we have, and we see that a certificate is about to expire, and the entry is now orange. So it is helpful to monitor on a regular basis for internal or external certificate expiration, and the tool will notify you in advance on this. Okay, let's move to automation. Let's check what application consists of. It consists of several libraries and main executable, which provides a user interface, but entire logic is hidden in SSL Verifier .core library, which is a standard .NET class library, which is accessible from PowerShell or external .NET project. So we can work with this library in PowerShell to automate scan in PowerShell console and put it possibly in a task scheduler. So let's move to it. I've opened PowerShell console. First thing we have to do in order to work with this library is to add types from that library. So use add type path and specify path to this file. So all types, all classes types from this library are imported to this PowerShell console session. First thing we have to create is a configuration for verifier. So create a config, new object, SSL verifier core. Okay, verifier dot core. Default. Okay, this is a namespace where a configuration class resides, and the configuration class is a sort of processor config. Okay, hit enter. We can explore properties of this object. So we have nearly same same settings as we have in UI dialog. So we can modify settings, say enable CPU lookup. Okay. Next step is to create a sort of processor class object. Okay. Processor is there. A new object, so verifier core. It resides in a slightly different namespace, SSL verifier for .core .processor. Okay, sort processor, and as a parameter we specify config. Okay, now we have to create a TLS server endpoint entry. So entry is a new object, SSL verifier core default. Okay, server entry. Yes, and what we will add. Okay, let it be revoked badssl.com. Specify default port 443. Okay, and now we execute scanning for this entry. So processor, start scan, specify entry. Second parameter is not used. Okay, and here is get evaluator and get result. Okay, now scanning is fired. Okay, and now we return the method returns some object which we don't care about because main work is for processor is to file properties in entry object. So we see entry object, server address, property, proxy not use it, and now details. Item status failed. That entire entry failed at some point. We can see all alternative names for that endpoint. Chain status is no error, but it failed. So tree property contains those certificate chains. We can flatten this tree into a plain array. So entry, tree, flatten, and we see entries for every certificate for every redirect. So name, errors, some information about certificate is root, errors, warnings. So this one is okay. Next entry is okay. Third entry is okay. Looks okay. Yes. Okay, and last one, revoked bad SSL.com is revoked, and native errors is revoked. So you can automate this with a simple script. Yes, like this one. Okay. So and okay, fail is pros dollar entry tree flatten and the condition where object what we have native errors not equal error. So and if and put a condition if fail, then fire actions for a failed entry. You can say send email, do call external process or whatever else you want on a failed entry. And you can use PowerShell to export export this entry object with all stuff into HTML report by creating HTML reporter, new object, SSL Verifier, core data, and HTML processor, and it requires configuration as input parameter. Okay, and HTML generate a report, and we pass this entry object entry. So, and the method will return you raw HTML, and you can use out file set content commandlet to save this HTML to a file.
Excellent. Well, Vadams, thanks so much for the demos there. And I think the automation that you've shown has a lot of potential to take the content of the verifier and use it in an automated way. I know we have a number of questions that are over on the tab. So with our few minutes left, I thought maybe we could turn over there and go through a couple of the questions that we have. And some of the items that had come up was Beth was asking about TLS 1.3 and still not widely in use. Do you have any experience with TLS 1.3, Adams?
I was reading specs for TLS 1.3, but haven't played with it much because Windows still doesn't support this TLS version. There are plans to get this support somewhere next year, and since we are relying on some S-channel APIs to establish a TLS session, so it isn't available for us right now.
All right. And then, Alaric, you asked about the September 1 change. I think I can summarize your question and your answer by answering it. The change is only going to affect certificates that are issued after September 1. So you were asking, what about existing certificates that you have that have a 2-year lifetime? Nothing will impact those. So the browser change is simply for new certificates issued after September 1. And I'm going to tie into that because I know we still get questions on our website of why are you talking about this, Mark? This is only supposed to be public certs. We have customers that have certificates that are coming from subordinated CAs from these public certificate authorities, as well as some of them have actually taken tools like Verify and Keyfactor and do enrollment and use publicly trusted certificates internally. So there is no absolute guarantee that this isn't going to avoid all enterprises. We're simply communicating it because there is a browser change, and organizations simply need to look at their infrastructure and say, A, are we potentially affected because we are relying on a external CA that a partner is providing for us? And B, there's always the possibility that certificate authorities may be inappropriately tagged as external versus internal. So we'd much rather be communicating this for visibility. There frankly is no intended effect internally, but we certainly wouldn't want people to be caught by surprise come September 1. Shrey had a question for you, Adams. They asked if this is platform independent, the SSL Verifier. I'm not sure if they were asking for different OSs, but maybe 32-bit versus 64-bit. Can you talk a little bit about the source code and what platforms it could be used on?
Currently, it is the tool is compiled to use it .NET framework 4.5, but I'm planning to compile a library under .NET Core, so it can be used on different platforms like Linux, Macs, where .NET Core runtime is installed. I'm not relying on any strictly Windows specific feature. I'm using APIs which are compatible with .NET Core. About the tool, it isn't yet available for download. Exactly this version. It will be available next week. So follow our website blog, or follow me on Twitter. I will announce when the tool will be available, and I will write a blog post which will show required comments in the PowerShell for automation. Source code is available on GitHub under PKI Solutions. So you can navigate to this repository and get sources from there. The tool is completely free for personal and commercial use, and it is open sourced.
And the previous versions we do have available today on the website. If you go to pkisolutions.com, under solutions, we have our open source tools listed there. So some of the newer features that Adam's talked about today, like the HTML report, will be in the version that he's just about to release. But if you'd like to see the other tools or get your hands on the version that is available now, you can get there. We also have links over to GitHub for the actual source code, as well as any of the other updates and details that we have there. The other questions that I'm seeing here are really back to the September 1 change. So we don't have time to get to all of those other September 1st browser changes. I do invite you to go to our blog. We have an article on this. There have been some questions that are answered there. If they don't address your specific question, feel free to leave a comment and we'll follow up there as well. But the September 1 change is coming up. Hopefully it'll be a minimal impact, but we definitely want people getting that visibility that is out there. So I'd like to take this opportunity to wrap up. Adams, thanks so much for the demos today. If anyone would like to follow up with Adams or myself, we're both on Twitter. I'm at the PKI guy, and Adams is at Crypt32. You can also follow up with PKI Solutions on Twitter or on our website. And make sure that you sign up for notifications, and we'll let you know when future versions of the SSL Verifier, as well as Adam's other tools like the ASN1 editor and the PSPKI are released as well. So once again, thanks for tuning in, and stop by next month for episode 7 in our webinar series. Thanks so much, and we appreciate everyone stopping by.
Yes, thank you very much.